All right, this is properties of logarithms, which are on worksheets 16, 17, and 18. And we're going to start by reviewing properties of exponents. When we had a problem like, say, well, it'd be better if I did x, probably you guys get confused. X squared times x to the fourth, you added the exponents and got x to the sixth. Okay? Product property of logarithms says that if you have two logarithms multiplied, that you can break them apart as an addition problem. Okay? Remember, they are just inverses of exponent problems. The quotient property would be if you had x to the 12th over x to the 4th, you would subtract and get x to the 8th. So when you have a logarithm of a division, you can subtract as two separate logarithms. And when we had something like x to the 3rd to the 5th, we multiplied and got x to the 15th. The same is true when you have a log of x to the 8th, you can multiply the 8 out in front, and I think we kind of talked about that a little bit last week. Do those problems all sound vaguely familiar, like you remember doing this last year and it was kind of confusing? Hopefully this year it'll start to click a little bit, make sense. All right, again, at the top of the worksheet you have are those rules. When you multiply, you can break it apart as an addition problem. When you divide as subtraction, and the exponent can multiply out in front. Be very careful, guys. This doesn't break apart, okay? If we did something like log A plus log B, that's distributing, and this is not a multiplication problem, right? It's the log of a quantity, A plus B. So this is different than if you had this. If it had started out as this, okay, you can do nothing with this. But if it started out as this, then you could have written it as log of A times B. Okay, two separate multiplication or addition right up here can be rewritten as a multiplication. Okay, but this does not simplify at all. All right. So there's an example done with numbers here. I did not assign very many of these because I know you, but there is a no calculator quiz, remember, later this week, like as in no calculator. All right. There is one page of it that is definitely calculator. It's using that finance menu and stuff, okay? But there are 3 pages of problems for which you need to understand logarithms and exponents. So if we had 3 log 2 of 8 plus 5 log 2 of 1/2, right here, this means 2 to what power equals 8? That would be a 3. So this becomes a 3 times this whole log becomes another 3. And this one is saying 2 to what power is 1/2? Well, what puts something in the denominator? -1, right. This whole exponent right here is -1. So we have plus 5 times -1, which is 9 minus 5 or 4. All right, that's what they got. They did a whole bunch of goofy stuff, but that's what they got. All right, this kind of problem is what we are going to have a lot of actually on that quiz as well, because you don't need a calculator to do this. You're just expanding. All right, we're going to break this all apart. There's some multiplication going on, so we could have ln 8. Then it's times, so we're going to make that a plus, the natural log of x to the 5th. Then it's divided by, so that'll be minus. And then down here we have the natural log of 3 times, which will be plus, the natural log of y squared. All right, now a couple things going on. You can't stop until those exponents are multiplied out front, so we need to move this one out front, and we need to move this one out front. And then I don't care if you leave this in parentheses or if you distribute this negative. They say this is the natural log of 8 plus 5 times the natural log of x minus the natural log of 3. Then they said minus 2 times the natural log of y, because they not only brought that 2 out in front, they distributed and got rid of the parentheses. So if you want to leave this down the bottom as a plus, then you need parentheses there. Any questions about that part? Oh, do you need me to go back? Are you sure you got it? Okay. There is one simplifying here. What would the log base 3 of 27 be? 3 to what power equals 27? That would be 3. So that problem would become 2 times 3. And log base 3 of 1/3 would be 3 to what power is 1/3, which would be -1. So this would become plus 4 times -1, which is 6 minus 4, or 2. Are we okay on that one? Definitely could use your calculator, right? I didn't put any like this on the no calculator quiz where you had to evaluate multiple things. All right, anybody think they remember enough of this to do number 2? Not so much? What's going on in the denominator? Does that say cubed root of t squared maybe? Okay. Can anybody make that into an exponent? The cubed root of t squared is really t to the... Okay, the cubed root means 1/3. So what is this altogether? Yes. Okay. T squared cubed root is t to the 2/3. All right, so if I separate this, I have log base 3 of 5. What does times become? Plus. Let me erase this. Whoops, thought I was going to erase it. All right, then I had r to the 5th. What do you want me to do with that? Okay, so we could bring out the 5 to the front of this particular, we could have written a log base 3 of r to the 5th, but then this 5 comes out front, okay? Don't forget the little 3 though. All right, then, yes?
How'd you get the 5 after the log base?
Because of this 5 right up here.
Oh,
Do you see it's 5 times r to the 5th? Yep. Good question. They're so tiny and there's so many of them, I don't know. Then down on the bottom, we discussed that this is really a 2/3 t, so we can do minus, because it's in the denominator, or dividing, and bring the 2/3 out in front, log base 3 of t. How'd that go? Maybe, sort of, kind of? Yeah, that's it. Expand means write it all out like this. Yep. All right. This is the log of a minus 2. And that's the numerator. Can we distribute that log? Nope. What are we going to do with the denominator? It'll be a minus. Back here, there's going to be a 5 log of b minus 2. But that 9, I think we can do as a separate log 9. Now, if we put a plus in here because it's multiplied, we do need parentheses around the whole thing because all of this is in the denominator. Does that make sense? Otherwise, we can distribute. We can say the log of a minus 2 minus the log of 9 minus 5 times the log of b minus 2.
The log with no number below it, isn't that log base 10 then?
Yes, you could write base 10 on all of those if you wanted, yep. When there is no base given, it is a common log, so it is base 10. Wouldn't be wrong to write those, but you don't need them.
Does that say minus 5 log? parentheses,
It's supposed to say minus 5 log b minus 2.
Okay. Thank you.
No problem. I thought I was doing better. It's better than last period. Last period is all over the place, but it's still pretty sloppy. Sorry. All right, condense. What do you want to do first?
We can put the 11 up here.
We can put 11 up here as an exponent and 5 up here. Be careful. The 5 is on the whole thing, the 2 and the x, just like the 11 was on the whole quantity x minus 3. All right, condense means write as a single logarithm, so we are only going to write log base 9 once. So what do we have left to do with this x minus 3 to the 11th and 2x to the 5th?
X minus 3 to 11 is going to be on top, and 2x to the 5 is going to be on the bottom.
Perfect. Now, I'm thinking I would accept that answer. Okay. I really think we could simplify just a little bit. Does anybody know what we could do?
We could do 11 and 5 and 6 on top.
Only if they're the same base here.
Oh.
If this was an x minus 3 and an x minus 3, then we could combine them. No, we can't do anything with the top, but we could get rid of the parentheses on the bottom. What is a 2 to the 5th? Yep. So we could write that as 32x to the 5th, and then we wouldn't need a second set of parentheses. But I don't care. Either way, I'll accept that one. But if you don't put the parentheses, if you just write 2x to the 5th, that's wrong, okay? Because the 2 is also to the 5th. All right, who's got this one? Anybody? We're going to have ln one time. What is a 3/4 power going to do? Cube, yes. 4th root. There we go. And plus means? Multiplies, so we're taking the log of all of that mess. And I know these are painful, but honestly, I took off some of the worst ones that this book had. They're just ridiculous. I mean, I don't really think they're that hard, but they're just, why would anyone ever need to expand 1,000 things? All right. And the final idea today is change of base formula. When you have something like log base 2 of 7, in exponent form, this means 2 to some power equals 7, yes? Okay. We could take the log of both sides here. We could go the log of 2 to some power equals the log of 7. Then we could bring this out front like we just learned today. And then we would divide. So we would say whatever that is really the log of 7 divided by the log of 2. That's the change of base formula. It says the log of x divided by the log of b. Okay, is this version right here, but I always just remember it as the log of the big number divided by the log of the little base number. Okay, now there is a change of base form that you can use on a TI-84, and you don't have to know this, okay? But I think most of you have had to learn this for science, change of base, because if they make you use a scientific calculator in your science class and not a programmable one, then you won't get change of base. All right, and it is true that you can use either version. You can also use ln. So could I have everybody type log 7, close the parenthesis, divided by log 2, and then try ln of 7 divided by natural log of 2. And then if you have a TI-84, I want you to actually find this little form that looks like that. And let me open my little Webbit up here. All right, so I can type log 7 divided by log 2. Got to close the parenthesis at least on the top, and I get 2.807. If I type natural log of 7 divided by natural log of 2, I get exactly the same thing. Doesn't matter when I took the log of both sides there, it didn't matter what kind I used. That is called change of base because it originally was log base 2 of 7, and I've evaluated it to be 2.807. Now, if you have an 84, it is under math, arrow up a couple times, and it says log base, and then it lets you type in those sweet little boxes. Okay? It is also under F2, so if you do alpha window, it brings up log base as a choice there. That's like the only shortcut key I know is log base.
So I can't, so when I did the second problem on the TI-83, when I did both natural log and log, I got different.
Then you didn't close the parenthesis on one of them? I'm guessing. You have to close the parenthesis on the top.
So log times log. Oh, that's okay.
Oh, you did one time log and one time ln?
Yeah.
Okay. All right, so what?
You do ln and also log.
You have to do both the same.
Both.
Okay, that's a good question. Yep. You have to do both the same when you're doing change of base. Okay?
If they're the same thing.
Was it 2.807? Is that what we said?
Yes.
Okay.
If they're the same thing, why can't you just mix them up?
Because that's what makes them the same thing, is that you're using the same base for both.
Oh, okay.
Okay, if you use base E for one and base 10 for the other, it's not going to be the same. All right, so whichever format you want to do, can we type this one in and see what we get? I probably would have done this over this because I always forget I have that little change of base. But you can use the change of base if you want. What should the top be, by the way? What is log base 10 of 10? I got negative 2.096. Anybody get that? Okay, so everybody's okay with change of base? That is not something you will have to do on the no calculator quiz, okay? All right, there's a few examples on the back side, I think. Is this the back? All right, I'm going to go through this top one really fast. You could break the 12 off as a multiplication. Because it's multiplied, it would become addition. Then you could bring the exponent out in front. So you would have 5 log of x. And then minus 2 log of y. Now, how can I have a minus when there was no fraction here? Guys, I'm trying to tie this together in your head.
Oh, because the
Y to the negative 2 does mean there was a denominator kind of thing, right? So that's why it's okay that there's a minus here. It's kind of like there was a denominator. All right, ln, this would be 2 ln of x divided by or minus 1/2. Square root is 1/2 power. ln of 4x plus 1, and we'd be done. We can't do anything with a 4x plus 1. We cannot break it apart any further. Yes?
Alright, so let's say for for part A, like get like that the expanded
Mhm.
equation, we had to condense it. Is it okay if we did that instead of
In the denominator, put it
Yes.
as a negative? I
Yeah.
would prefer you wrote it in the denominator.
Okay.
Okay, good question, though. All right, who's got 3A? I don't know why they use log base 13. That's just evil that we have to write that out like 3 times. But log base 13 of what?
Actually, it would be 3 log base.
No, actually, because the 3 is only on the A, and we got to get rid of that 6 first.
Okay.
So it's log base 13 of 6 plus, then you're going to have 3 log base 13 of A. Then what, guys? I can't even read all that.
B, C, 4.
Log base 13 of B plus, one more, I don't think I want that on the quiz just because I don't want to have to grade all those. The little 13 seems like a total waste of time, right? All right, what about 3B right here? Can anybody write that one out? Do we separate the top? Nope, it's just ln of 3y plus 2. Okay, then what? It's an ln of 4, and then I think a cubed root of y, yep.
Oh, that's a Hebrew one.
Now, do you want a plus in here or a minus? You want a plus? Okay, it's not right. Unless we put some parentheses here. And that's fine, because all of this is in the denominator, so it's all minus. Or you can write it with the minus distributed. I don't care, I'm not going to count one right and one wrong, but you got to hit the right signs or the parentheses. All right, and then the ones that are much more fun, condensing them into a single log. It's much less painful, I think. Anybody want to try this one? 4A? I'm not doing the examples up there. I'm going to just go straight to these.
Write down log base 2 once.
Log base 2 one time, exactly.
And then you have x plus 1 to the 5th. And then times 6x to the 3rd.
Okay. And what does it mean that it's to the negative 5th? Yeah. We really should rewrite that one. Log base 2. Can we get rid of one set of parentheses here? What is a 6 to the 3rd and an x to the 3rd? Six to the 3rd is 216, right? Did I do that right? So 216 x to the 3rd, we get rid of those parentheses. And then that one I'm just going to move to the bottom. If you left it 6x all to the 3rd, I probably wouldn't count it wrong, just so you had the parentheses still. All right, who's got this one? Ellen. Carrie, you got something down or not yet? Tell me what you have. Did you leave the x minus 1 on the bottom? Okay. This is right. Unfortunately, I wrote my ln clear over there, which it shouldn't be. Or my fraction bar. It's the natural log of 3x plus 5 over an x to the 4th and an x minus 1. Everybody okay? All right, anybody want to pick a question? Oh, there is a little, I think you have this somewhere in your packet, but one more time, it reminds us that there's no such thing as like distributing a log, okay? Through a addition or subtraction. Don't do it, don't do it, don't do it. Is there anything looking nasty that you want me to talk about?
Number 7.
Could you do
Number 7? This?
The actual properties that I'm talking about beyond.
Okay. I think they're just there to throw you off. They're really not necessarily. I think it's just 3 log base. Oh. All right. Log base 2 of 2x, which really isn't fully expanded yet, is it? Okay. Plus log base 2 of x plus 1. You do have to do all of these. It says on the worksheet that we would do some together, so if you don't want me to take time to do all the odds together or the evens or whatever, then they are all assigned, so.
So if you do 3 log base 2 times 2 and 3 log base 2.
Yes, I'm still doing 7, by the way. You could write log base 2 of 2 plus log base 2 of x, and that 3 was on all of that.
Oh.
Does anybody see something we could simplify there? Yeah, what is log base 2 of 2? It's 1. So this is really just a 1. So if we distributed that 3, you could write 3 plus 3 log base 2 of x plus log base 2 of x plus 1. I'm pretty sure I would take any version thereof, okay?
Okay, I'll do.
That one's just way too complicated. The one on, one like number 9 or number 10 or even number 6 or number 5, that's more likely to be on the test or quiz. There's just too many versions that are really correct of this one, okay? But Sean had a good point, guys. It says on the pink sheet that we were going to do either the evens or the odds together. Do you want me to do a few more together? Otherwise, the whole thing is assigned, okay? You want to do a couple more odds together?
Yeah.
What's number 5 going to say?
Times x plus 1 minus ln x.
Perfect, except don't say times, because it really isn't times, it's ln of x plus 1, okay? Yep, but you did it, I knew what you meant. Bryce, can you try number 9? What did you do? What do you have down? Good job. It should be all in a row. I just ran out of room. Go ahead.
So it's all parentheses, you can't split it apart, correct? Like, in the paper.
As long as it's adding and subtracting, it cannot be split apart, yes. Okay, in number 7, we did split apart because the 2 times, multiplication can always be split apart, the 2 and the x.
And 8 or 10, can you split apart?
No, because of the addition, no, good question, yep. On number 8, this is just gonna be 3 log base 8 of 4x plus 2, because of the addition going on in there, it's kinda like glue, okay? It's all still stuck together. Nothing else you can do with that one. Do you want to condense a couple or not?
Yes.
Which one?
15.
Okay. The plus will become multiplication, so we'll have y and a 3. I'm just going to write 3y. And then it's minus, so that's what? Divided by, and the 1/3 is cubed root of x. Now, Normally I'd say we can't leave a cubed root in the denominator, but I'm not going there. I'm perfectly happy with that, okay? The book actually, a couple of them, they did rationalize denominators. I'm like, ugh. Did I lose you?
Oh, I'm good.
You're good? Okay. Anything else on here? These three are just typing.
Here's the 23.
Yeah, this is also really just typing. It says that the magnitude R is the log base 10. I don't know why they wrote that, log base 10. They never usually write base 10. Of I over I sub 0. But then it proceeds to say use I sub 0 as 1. So basically just get rid of that. So it's saying R equals the log of I. And it says when R is 6.7, how can we find the intensity of that? Can you rewrite it? How would you rewrite?
6.7.
Yep, 10 to the 6.7. And this one's going to be 10 to the 7.1. But you do need to type that in and figure out what it is. It's a big number, both of them.
Do you want, how do you want?
I don't know that it has a, it just says the intensity of a shock wave. Oh, it says intensity per unit of area. That doesn't tell me anything. So I just wrote it down as a number. I didn't label it.
Like, I mean, like, what do you, want us to round it to?
Whole number's fine. Yeah, they're big nasty numbers. Okay? Anybody else have a question? Otherwise, I'll pass out the homework check. All right, hopefully properties of logarithms are pretty straightforward and you remember some of it from last year.
On the back page